Hello, in this video we are going to review three division methods. We're going to start with the standard algorithm, then partial quotients, and then area models. In this problem here, it says enter the quotient. We have 335 divided by 5. Now, to set up the standard algorithm on the side here, I'm first going to rewrite this problem, taking my dividend and writing my division bar with my divisor of 5. I'm going to take a look at the 3 and the 3 here, 33. 5 times what number gets me really close to or exactly to 33? Well, 5 times 6 is in fact 30. Now, I can't do 5 times 7. 35 is close to 33 as well, but we cannot go over 33. So now I'm going to subtract. And I still have another digit here in my ones place. So I'm going to bring down this 5. 5 times what number gets me close to or exactly to 35? 5 times 7, which in fact is 35. Subtract, and we are left with no remainder. So my quotient in this problem is 67. And just like all these problems on an Edge Elastic assignment, you're always going to see that box. That's where you're entering in your answer. In this next problem, we have 708 as my dividend, and we're dividing this by my divisor of 6. I'm going to look at the digit in my hundreds place. 6 times what number gets me closer exactly to 7? 6 times 1 is 6. Subtract, and we're left with 1. Now I go to my next digit in my tens place. Bring down that 0. 6 times 1 is in fact 6. That gets me very close to 10. Now 12, 6 times 2 is 12, but that's too big. So now I have 10 minus 6, which you might know is 4. You can also borrow here if needed. 10 minus 6 is 4. Now I bring down my 8. 6 times what number gets me close to or exactly to 48? Well, in fact, 6 times 8 is 48, and this is great. That means we're also going to have no remainder. So my quotient here would be 118. Now in this problem, it says, what is the quotient for the expression 2,314 divided by 4? So again, we're going to take it one step at a time. 4 times what number gets me closer exactly to 2? Well, 4 times 0. So I'm going to now look at 23. 4 times 5 is in fact 20. That got me close to or exactly to 23. I'm going to subtract, and I'm left with 3. Now I still have a digit here. I'm going to bring down this 1. 4 times what number gets me close to or exactly to 31? Well, 4 times 7 is 28. So now here, 1 minus 8, we cannot do that. Let's borrow here. And this 1 becomes an 11. So 11 minus 8 is in fact 3. Now we're not done yet. I still have a digit in my ones place. Going to bring down this 4. And now I have 4 times what number gets me closer exactly to 34? Well, in fact, 4 times 8 is 32. And now I'm going to subtract here, and we're left with 2. Now 2 is in fact my remainder. So now I have 578 is the quotient with a remainder of 2. Now, to make sure we did this problem right, we can always check our work. Looking at my quotient, we have 578 times my divisor of 4. Now, if we do this multiplication pretty quickly on the side, 4 times 7 is 28, plus 3 is 31. 4 times 5 is 20, plus 3 is 2,312. Now, looking here, notice this is not my dividend yet, because I have a remainder in this problem. I now have to add that remainder of 2, which now I'm like, yes, I did do this problem correctly, because my answer is the same as my dividend, and that's how you know you did it correctly. Now for this problem here, we have 432 divided by 8. Now, unlike the other problem, we are now going to try partial quotient. So we're setting up a little bit differently. So instead of writing our quotient on the top, we're going to write it on the side here. So I'm going to do just like I did in the last problem and take a look at 43. 8 times what number gets me closer exactly to 43? Well, 8 times 5. Now, instead of writing my 5 on top here, my tens place, we're going to write it on the side. So 8 times 5 is 40. And now we're going to fill in the space here with our 0 and another 0. And notice 8 times 50 is 400. Now I'm going to subtract, and I'm left with 32. So we're not done yet. 8 times what number gets me close to or exactly to 32? Well, this is great. 8 times 4 is 32. I subtracted, I'm left with no remainder. Now to find my quotient, I need to add everything on the side. So 50 plus 4 is in fact 54, and you can always bring your answer up on the top here, telling me that my quotient to this problem is 54. Now in this problem here, it says there were 4,536 tickets sold at the carnival. Each ticket, keyword for division, each ticket cost $8. How many people were at the carnival? So to figure out how many people were at the carnival, if we know that this amount of tickets were sold and each ticket cost $8, we are in fact going to divide. Now I'm going to use partial quotients again for this problem to solve. So first I'm going to do very similar like I did in the last few problems. 8 times what number gets me closer exactly to 45? Well, we learned in the last one, 8 times 5 is 40. The same thing here. Now here I'm going to fill in my spot here with a 0 and another 0 and the 2 zeros here and here. Now 8 times 500 is in fact 4,000. Now when I subtract here, I'm left with 536. I'm going to take a look at 53. So now I'm asking myself, 8 times what number gets me close to or exactly to 53? So if I know that 8 times 5 was 40, 8 times 6 is 48, and 8 times 7 is 56, but that's way too big. So 8 times 6 is 48. I want to fill in my 0 and another 0. Telling me that 8 times 60 is 480. Now I'm going to subtract here. 3 minus 8, well, can't do that. Let's borrow from the digit in my hundreds. That's 10. Now this becomes a 13. So 13 minus 8 is 5. So now 8 times 7 is 56. I'm subtracting and I'm left with 0. But now to find my quotient, I have to add everything on the side here. So that's giving me 567 as my quotient, and I have no remainder here. So how many people were at the carnival? 567 people. It's a lot of people at the carnival. Now for this problem here, we're going to use an area model. And if you take a look here, we have 4,983 divided by 31. Now my divisor here is a double-digit number. Notice it's 31. In the other problems here, my divisor was 8. I had 8 again, and here we had 4. So notice in the other problems, when it was a single-digit divisor, using the standard algorithm or partial quotients is much easier than doing an area model. But if you chose to do those methods for a problem like this, they will work, but you're going to find that you're guessing and checking a lot. You're going to be doing a lot of multiplication within that division problem, and it can become very difficult. But when you see that double-digit divisor, this is your time to use the area model to solve. Now, right away, these problems can look a little overwhelming. So the first thing I like to do is list out my math facts that I'm going to be using for this problem. So I have 31 times 1, 31 times 10, 31 times 100. And then I multiply by 2 and by 5. Now I chose 1, 2, and 5 just because those are easy facts to recall. If I chose 31 times 7 or 31 times 9, that would work as well. But 1, 2, and 5 is usually easier to recall. So 31 times 1, well, that's easy, 31. 31 times 10 is 310. And 31 times 100 is 3,100. Now, 31 times 2, you can write that on the side, or you might know 31 times 2 is in fact 62. So now here we have 62, and I'm just going to write 62, 62, 62, but notice we have 20, add our 0, 200, add 2 zeros. Notice those patterns. Now I have 31 times 5, which you might also want to write out on the side just to confirm you got the correct answer. 31 times 5 is in fact 155. And again, 31 times 50 is 1,550, and 31 times 500 is 15,500. Now, obviously, this is way too big. We're not going to be using that. My dividend here is only 4,983. I just write all of these out of habit. Now I'm ready to set up this problem. I'm going to do each step in a different color so you guys can easily see what we have to do to solve. So first thing, my dividend goes in my corner here, 4,983 divided by my divisor of 31. I'm going to ask myself here, 31 times what number got me close to or exactly to 4,983? Well, looking at my chart here and looking at all these facts that I have, I see that 31 times 100 got me really, really close. 31 times 200 also did, but 6,200 is too big. So I'm going to use 31 times 100, which is 3,100. Now I'm going to subtract here. So 9 minus 1 is 8, 4 minus 3 is 1, and I have 1,883. Obviously, I can continue going. So I'm going to draw a line going to my next step, and I'm going to bring this 1,883 up to the top. Now I'm going to do this next one in green. So 31 times what number gets me really, really close to 1,883? Well, looking at my numbers here, I see that 31 times 50 got me really, really close. So I'm going to use 50. 31 times 50 is 1,550. Now I'm going to subtract. 8 minus 5 is 3. 8 minus 5 is 3. So I'm left with 333. Now notice for each of these, I'm keeping everything lined up and nice, neat, and organized. That is key to success in solving these problems. So now I'm going to draw a line. I'm going to have 333 again. 31 times what number got me close to or exactly to 333. So I'm looking here at my chart and I see that 31 times 10 is 310. That's great. That's really close. So 31 times 10 is in fact 310. Now I'm going to subtract. 3 minus 0 is 3. 3 minus 1 is 2. And then 0. Now 23 is a pretty large remainder, but I know that is okay, and I know I'm finished because my remainder 23 is less than my divisor. When you are dividing larger numbers and you have a larger number as your divisor, you may also have a large remainder, and that is okay. So now we're very close to finishing. Step to do right now is now to take everything from up here and we're going to add this together. So we have 100 plus 50 plus 10, which is 160, remainder 23. Now after doing all of this work, we want to make sure what we did is correct. So I'm going to take my quotient of 160 and multiply it by 31, of which is my divisor. So 1 times 0 is 0, 1 times 6 is 6, and 1 times 1 is 1. 3 times 0 is 0. 3 times 6 is 18. 3 times 1 is 3, plus 1 is 4. Now when we add this together, we get 4,960. But we're close. We have to take our remainder of 23, and let's add this together. So that's giving us 4,983, which we know this is correct because look up here. That is in fact my dividend that was given to us. So we know after doing all of this work, we know that our answer is correct. As you continue to practice division, you are welcome to select any strategy you would like. This video reviewed the standard algorithm, then partial quotients, and now area models. Like I said before, standard algorithm and partial quotients is a great method when you have a single-digit divisor. When you have a double-digit divisor, I encourage you to try the area models. Now, as always, feel free to refer back to this video at any time as you continue to practice all three division methods.